let's look at the mantle. One thing I want you to know about the mantle, we said it's about 80% by volume. But the other thing we want to say about it, it is composed primarily of a silicate rock. And that rock is rich in magnesium oxide and iron oxide. In fact, we usually have a word for the rock that occurs in the mantle. We call this ultramafic. Ultramafic, which means it's obviously very rich in this mafic material. And mafic, think of this M for the magnesium and the F here for the iron. Remember, the chemical symbol for iron is Fe. So ultramafic. And the rock that we usually describe here is a rock called peridotite. Peridotite. Peridotite is important for several reasons. We'll talk more about that later, but it's a rock of the mantle. And that has that density from about 3.3 to about 5.7 grams per centimeter cube. But one thing I want you to know is that the mantle, because if we look at our model here, S waves are moving through it, right? Moving through the entire mantle, which tells us that for the most part, the mantle is going to be solid. Mantle is solid. Right? Mantle is solid. It may be weak or behave as a plastic solid, or but for the most part, it's going to be solid because seismic waves travel through it. Now, let's look at the crust. Remember, the crust is going to be the thinnest part of Earth, and that's the one where we're going to have either the oceanic crust or the continental crust. So let's look at oceanic crust. And remember, we said this is anywhere from 5 to about maybe 10 kilometers thick, whereas continental crust is anywhere from about 15 to about 50 kilometers thick. So there's a variety there. It'll be thicker under mountain ranges of continental crust. Another thing I mentioned here is something called an active margin and versus a passive margin. So active margin versus passive margin. Active versus passive in terms of plate tectonics. So one thing I want you to understand about this active, I always define it as the edge of the continent is marked by a tectonic fault. Edge of continent marked by a tectonic fault. And that fault could be like the San Andreas, right? Often we look at these in terms of something called a subduction zone. And so at subduction zones, you'll have a deep ocean trench, and then you'll come up along the continental slope to the continental shelf, and then you're over here in the land, right? So we'll put sea level here. So let's say this is the ocean here, and this will be our trench, a deep ocean trench. What's happening here, the tectonic plates are converging along this margin. So we said this thing here was a shelf, and this here is a slope. And then usually we have very high mountain ranges in these active margins, like California or the west coast of the USA. So you think of this as west coast. San Andreas Fault. If you go up to Northern California, you see the Cascade volcanoes in California, Oregon, and Washington. A passive margin, this one is where the edge of the continent is not marked. Edge of continent is not marked by a plate tectonic boundary or by an active fault. And so here we're looking at the east coast of the USA. There, the mountains are far from the ocean. There's a wide coastal plain. And if we were to draw a margin like that, we'd see we'd have the Appalachians, which are not very big, a very large coastal plain, and then we go down to the slope and then the ocean floor. And so we'll put sea level right about here. So this is the ocean here. We still have our shelf, just like we had here on the west coast, and the slope occurs here. But the thing that's different is that there's a thick packet of sediment that occurs here, marine sediment, and this packet is called a continental rise. And then here's the deep ocean over here. So note that there's an active fault here at the active margin, but there's no fault here. In fact, if we're looking at North America here, the western margin of the North American tectonic plate is basically the ocean trench off of Northern California, Oregon, and Washington. The eastern margin of the North American tectonic plate goes past the Appalachians, past the shoreline here, eastern seaboard, out past the shelf and slope and into the ocean, and not till you get to the mid-Atlantic ridge. That's the other end of the North American plate. So another word we use to describe these passive margins, we call these trailing continental margins. Trailing continental margins. Those are also known as passive margins. All right, well, let's stop here.